Welcome to or back to Through Inquisitive Kids. In this video, we will be learning all about the substitution method. In here, we will be covering the flexibility in substituting one equation into the other, learning the principle of solving systems of equations. In the last lesson, we learned all about systems of equations, as well as their properties and definitions. That was our introduction to systems of equations. In this video, we will be starting the first part of the second lesson, simplifying systems of equations. As you can see, there is a part 2 as well to this, where we learn about a different method to help us simplify systems of equations. You already know how to simplify one equation by now, right? Combining like terms, subtracting the same value from both sides. That's part of solving one linear equation in one variable. But how do you do that to a set of equations where there's not just one variable but multiple? Let's first get into the lesson. Our learning goal for today is to master the substitution method to eliminate variables and to use the substitution method to solve systems of equations. Solving systems of equations using substitution. The total weight of an apple in a pear is 200 grams. The weight of an apple plus the weight of 10 grams is exactly equal to the weight of a pear. How much do each of the apples in pears weigh? Being fairly new to systems of equations, we can first create a drawing. So here we have x plus y, right? X here represents the apple, and y here represents the weight of the pear. And that added together is equal to 200 grams. I don't know if you can see this, but this is written as 100 grams and 100 grams. So altogether 200 grams. We also know that the weight of the pear is equal to the weight of the apple plus 10 more grams. So here we have an apple plus 10 grams. So as you can see, they're both on a scale, and that the scales both weigh the same. How can we turn this into a mathematical language? Well, first we have the two variables, and the scale we can think of as an equation, right? So as the equivalent symbol. So we have a pear and an apple. So we know that one pear is equal to the apple plus 10, and we know that an apple plus a pear is equal to 200. Both the pear here and the pear here have the same weight. And since we know that one pear is equal to an apple plus 10 grams, we can plug this value into here. So instead of writing apple plus pear, we can rewrite it as apple plus 10 is equal to 200. See how that changes this dynamic completely? So here we went from two equations, two variables, into one equation, one variable, which is something that we do know how to solve. So now let's replace the apples with x, and we replace the pears with y. So if you can't see this, this is y, y, x, x. Okay. So we replace the apples and pears with variables, x and y's. X plus y is equal to 200. Y is equal to x plus 10. So here, what we have is equation number 1. So we write equation 1 and 2 just to understand which equation we're referring to. For example, you could say, substitute equation 1 into equation 2. So that way I'll know exactly what equation you're referring to. So we know that y is equal to x plus 10, right? And the bottom equation down here used to be x plus y, but y is equal to x plus 10, so replace y with x plus 10. That does not change the value at all because we know that y is equivalent to this other value in the first equation. So after substituting, we get this equation right here. So therefore, x is equal to 95. You can rewrite this as 2x plus 10 is equal to 200. 2x plus 10 is 2x is equal to 190. So x is equal to 95. Therefore, if you substitute this value back into the first equation, you add 10 to x and you have 105 for y. The solution to the system is y is equal to x plus 10, x plus y is equal to 200. The solution would be x is equal to 95, y is equal to 105. As you can see, even the solution, we have it combined with brackets. So that's something that you should pay attention to when you're writing your answer. The idea of reducing the number of variables and then solving them one by one is the concept of elimination. This is important because we don't really have a direct way to solve systems of equations in 2 variables, 3 variables, multiple variables. We only know how to directly solve for a linear equation in 1 variable. So what we can do is convert, using substitution, to convert a system of equations into a linear equation in 1 variable, using substitution. So this way we can eliminate y, for example, by substituting it, and then we only have x's in this equation. Knowledge key point. The idea of solving systems of equations to eliminate is as much variables as possible. So we first have a linear equation in 2 variables. After we eliminate a variable using substitution, we have a linear equation in 1 variable. The substitution method is used for eliminating variables, where variables are replaced by others in order to minimize the amount of unknown values in a function. And also, to clarify, if you have a system of equations and you see that you have 2 variables but only 1 equation, it means that that's unsolvable. But as long as you have 2 separate, you have the same number of different equations, and the number of variables, and both of those, the amount of variables in different equations are the same, that set of equations is solvable, always. So if you have 2 variables, you need 2 distinct equations, 3 variables, 3 distinct equations. And why I say 3 distinct equations is, for example, x plus y is equal to 4, right? And 2x plus 2y is equal to 8. So this will not work because when they're in their most simplified states, they're still equal to the same thing. So this counts as the same. This counts as the same function, the same equation. And since there are 2 variables, x and y, this system of equations cannot be solvable. But that's a topic for another lesson, so this is just a quick overview to what we will be covering later. The substitution method is one of the most commonly used methods for solving binary linear equations, or linear equations in 2 variables. Example 1. Using what you've just learned, solve the system of equations 3x plus 2y is equal to 14, that's equation number 1, and equation number 2. X is equal to y plus 3. Pause the video to see if you can use the substitution method to solve. Here, what equation do you have to substitute into the other? Well, you can substitute 2 into 1. Okay, so this is the wrong order. This is substitute equation 2 into equation 1. And you get the following expression. And simplifying it, you have y is equal to 1. And then substitute y is equal to 1 into equation 2 again. So x is equal to 4. After checking, remember to always double check because you can make mistakes anytime. Especially even if you're a beginner right now, you still need to check just to make sure. That's always a good habit, whatever you're doing. So this would be a valid solution to the system of equations. Therefore, the solution is x plus 5, y is equal to 2. See how in my solution I have it lined out like this, and I also have a separate line just to state the solution. This is what your work should look like every single time you show your work for solving a system of equations. And as you can see, again, always put this in the proper appropriate form with a bracket that's grouping up together the two values, x and y. Solve the next system of equations. Pause the video again to solve. So here this is a bit different, and what you have to do first is convert. So from equation number 2, we could just sort of rearrange the terms, and if we subtract 4y from both sides, it doesn't get rid of any variables, but it does create space for x to go onto one side of the equation. So this equation we can call equation number 3. Substitute equation number 3 into equation number 1, and then we have this equation right here. Simplify, y is equal to 2. Again, now you can substitute that into either equations 1 or 2 or 3. If you substitute into equation 3, you have x is equal to 5. So the final solution is x is equal to 5, y is equal to 2. Example 3. So we're doing a lot of practice right now. Solve the system of equations x minus 1, y is equal to 3, 3x minus 8, y is equal to 14. Think about how you converted the equation into, without eliminating any variables yet, but isolating one variable onto one side of an equation. Think about how you can do that right now. Well, for equation number 1, so equation number 1 is not written right now, but we can just write equation number 1 here, and equation number 2 for this one. So equation number 1 can be rewritten as equation number 3, which is x is equal to y plus 3. This is our converting system, a step. And then is substitute. Substitute equation number 3 into equation number 2. So 3 times the sum of y and 3 minus 8y is equal to 14. Solve, and then you have y is equal to negative 1. Substitute y is equal to negative 1 into equation number 3, and therefore x is equal to 2. Solution. The final solution would be x is equal to 2, y is equal to negative 1. Here you have the entire system, the solution, split into 5 distinct steps. Convert, substitute, solve, substitute, and solution. So here you have to substitute 2 times because there are 2 variables. If there are more variables, you just have to substitute more. Can you substitute equation number 3 into equation number 1? So yeah, let's think about this question. Equation number 3 is x is equal to y plus 3. But can you substitute that into equation number 1? Well, let's first try. If we substituted x and replace that in here with y plus 3, then you'll have y plus 3 minus y is equal to 3. Let's simplify that. So y minus y is canceled out, and of course 3 is equal to 3. This doesn't make sense. This doesn't give us any more progress because technically you can think of equation number 1 and equation number 3 not as 2 distinct equations. Again, as I covered, it was just sort of rearranging the different terms. It didn't add or eliminate any other terms. So it doesn't really make sense to substitute it in. You could, but it doesn't have any, it won't help with solving the system of equations at all. So now let me ask you a question. Why can variables be replaced or substituted? Well, the answer is that 2 expressions can represent the same value. So really think about this. 2 expressions can represent the same value. This is substitution. How has the system of equations changed before and after substitution? Systems of linear equations in 2 variables can be turned into linear functions. And if you think about it, linear functions is really, you probably know about this because we covered this earlier on. You probably know mx plus b. where m and b are parameters and y and x are variables. So this is a sort of linear function, as you can see, there it's an equation with two variables. So systems of linear equations in two variables can be converted into a linear function. So substitute and elimination of variables. Let's take this one step further. If the function yx to the 2m plus n power plus 4y to the 3m minus 2n is equal to 9, and that's a linear function in a linear equation in two variables about x and y, find the value of m and n. And whenever you see a question say about x and y, it means that x and y are the two variables in this case. So what is the value of m and n? Well, really think about the definitions of linear equations in two variables first. X and y both have exponents. And it's a linear equation. In this word linear here is saying that the degree of each variable in this equation has to be 1, meaning that 2m plus n has to have a value of 1, so does 3m minus 2n. So here's a solution. A system of equations can be formulated according to the known conditions. Here we have equations 1 and 2, and both of these are equal to 1. We can convert 1 into n is equal to 1 minus 2m, isolating n on one side of the equation, and call that equation 3. Let's substitute equation 3 into equation 2. And when you have 3m minus 2 times the difference of 1 and 2m is equal to 1. So therefore, m is equal to 3/7. Now let's substitute m is equal to 3/7 into equation number 3. And then we get n is equal to 1 minus 2 times 3/7. Therefore, n is equal to 1/7. M has a value of 3/7 and n has a value of 1/7. Okay, now I just want to quickly go back, and this is not the point of this lesson, and it's fine if you don't understand yet, but there's another way we can actually substitute this. Did you find out where? Well, both equation number 1 and 2 equal 1, meaning that they really equaled each other. So why don't we substitute this 1 here with 3m minus 2n. After substituting, we'll surely get equation number 3, a different equation number 3. Applying the substitution method. Okay, example 4. According to the market research, the ratio of sales volume calculated by bottle of research and disinfectant in large bottles, 500 g, in small bottles, 250 grams, is 2:5. A factory produces 22.5 tons of this disinfectant every day. How many bottles of these disinfectants should be divided into large and small bottles? Well, our equivalent values here are large to small. Their values of large to small is equal to 2 to 5. That's given in the problem. And we also know that the large bottles plus the small bottles is equal to the total amount that was produced. So let's create a solution out of those two main pieces of information. We can set x to represent the amount of large bottles produced and y to represent the amount of small bottles produced. And here are the relationships that can be obtained. Now we have our system of equations. We have 5x is equal to 2y, and that is our ratio. Our second equation is obtained from the amount of grams per large bottle and amount of grams per small bottle, and that all of that added together is equal to the grand total. That's equation number 2. And now it's just simplifying. And as you can see in the first video, which was the last video lesson of this unit, I said that when solving a problem that includes system of equations, I feel like the hardest part really is to create the right variables and the right equations. After that, it's really just solving for the variables, and there's a set of steps to that, and that's always something that you can refer to if you ever get lost. So really the hardest part is to set up the equations. So let's get into the solution. Convert equation number 1 into y is equal to 5 halves x. So that would be equation number 3. Now substitute 3 into 2, and therefore we have the solution x is equal to 20,000. And substitute x is equal to 20,000 into equation 3. And solved, we have y is equal to 50,000. So our final solution would be x is equal to 20,000 and y is equal to 50,000. But since this is a word problem, we still have to answer using a full sentence. Among the disinfectants, there are 20,000 large bottles and 50,000 small bottles. Now here is the overall steps that we have to do in order to eliminate variables in a system of linear equations and two variables using the substitution method. This is something that we have been working with throughout every single problem in this video. Here is the system of equations that we had from the previous problem. Here we have system of linear equations in two variables. After converting the first one, we have y is equal to 5/2 x. Substitute that into the second equation, and we have, so substituting this third equation into the second equation, we can eliminate y. So after eliminating y, we have a linear equation in one variable. Solved, x is equal to 20,000. And then substitute x is equal to 20,000 back into this third equation. Solve that, and we have y is equal to 50,000. Okay, so here is just the solution for another problem. In a basketball league, each game must be divided into winners and losers. So there's no ties. You either win or you lose. That's the rules. With 2 points for a win and 1 point granted for a loss. The team wants to score 35 points in all 20 games in order to strive for a better ranking. How many wins and losses did the team have? So here's our solution. Let the amount of games won is x and the amount of games lost is y. And so the system of equations that is obtained could be x plus y is equal to 20. That's equation number 1. Equation number 2 consists of 2x plus y is equal to 35. From equation 1, you can convert it into y is equal to 20 minus x, and that is our third equation. Following the similar steps as the previous problems did, we can substitute that new converted equation into equation number 2. And therefore, we have 2x plus 20 minus x is equal to 35. Solved, x is equal to 15. Now we substitute that value into equation number 3, and we have y is equal to 5 after simplification. So the final solution is x is equal to 15 and y is equal to 5. But pay attention that this is a word problem. So your final answer would be the team won 15 games and lost 5 games. Class summary. Today we learned all about solving systems of equations. We learned about the idea of eliminating variables and steps for solving systems of equations by substitution. And there are 4 main steps. First, we convert. Then we substitute, simplify, and answer. About the conversion, I just wanted to tell you that it's not really creating a new equation, it's just sort of rearranging the terms you already have, not adding nor deleting any ones that you already have from the original equations. And substitute. Substitution is really thinking of the idea that, oh, so formula expression A is equal to something. And expression B is equal to that same something. So therefore, I can substitute B into A and A into B. Third step is simplify. Simplify to find the value of two variables. That's something that we have covered in previous grades and lessons, how to simplify a linear equation in one variable, so I'm not going to go into that. In answering, always answer the problem with your solution in an appropriate form. If it's just asking for the solution to your system of equations, make sure to add brackets. And you know what, just always add brackets, because even if it's a word problem, you still want that to make sure that you yourself don't confuse yourself. And if it's a word problem, always answer in the correct units and check the question to make sure that you're answering the question appropriately. So that's sort of just basic word problem stuff that you should always follow. Again, to review, the 2 skills we learned today is to master the substitution method to eliminate variables, as well as to use the substitution method to solve systems of equations. Thank you so much for watching through Inquisitive Kids. If you haven't yet, please add a like, add a comment down below. And of course, remember to subscribe for our next coming videos. See you in our next lesson.